Hello everyone. Today I'll be working on Webwork Homework 10, Problem 10. So the first thing that I like to do is get all of my data in one spot so I can just plug it right in. So we have that a mass of 625 grams is attached to the end of a spring that is stretched 160 centimeters by a force of 16 newtons. At time t equals 0, the mass is pulled 2 meters to the right, stretching the spring, and is set in motion with an initial velocity of 7 meters per second to the left. So we have a mass of 625 grams, which works out to be 0.625 kilograms. The distance it's pulled, so you've got your distance and the force that is used to pull it that distance. The distance is 160 centimeters, which works out to 1.6 meters. The force is not this mass. It's not due to this mass. It is 16 newtons. So it says it's stretched 160 centimeters by a force of 16 newtons. So this is a different force that's stretching it 1.6 meters. But it can be used to calculate the spring constant. Now, for the initial value information, it's important to note that in this, right is positive. Pulling it in the rightward direction is positive. The reason we know that is because it says it's pulled 2 meters to the right, which stretches the spring. If it compressed the spring, if it was pulled to the right and it compressed the spring, then obviously that would be in the direction. Obviously the spring in this case would be on that side. So we know that pulling it that way is the positive direction. We also know that because it says in part B, it says positive displacement means the mass is further from the wall. In this case, further from the wall means it's going to the right. Okay, so for part A, we have, as I said before, you have a 16 Newton force causing the spring to move 1.6 meters. So our spring coefficient is 10 newtons per meter. In part B, we have no damping constant, so we just have the mass times the second derivative plus the spring constant times the distance equals 0. So just 0.625 x double prime plus 10x is equal to 0. And then we can solve that relatively easily. 0.625 r squared plus 10 is 0. Move everything over, and we end up with r is equal to positive negative 4I. So we have x is c1 cos 4t plus c2 sine 4t. Then we can plug in our initial value information. They said it started out 2 meters to the right, which is positive 2 meters, and starting at 7 meters per second to the left, which means it's negative 7 meters per second. So I first plugged in 2 is equal to c1 cosine of 0 plus c2 sine of 0. The sine makes this whole thing 0. The cosine of 0 makes this part 1. So you just have the c1 equals 2. Then I rewrote my my problem as x equals 2 cosine 4t plus c2 sine 4t. Found the derivative. X prime equals negative 8 sine 4t plus 4c2 cos 4t. Then I plugged in my negative 7 meters per second. The sine becomes 0. the cosine becomes 1, and you end up with 4c2 equals negative 7. So c2 is equal to negative 7/4. And then I can rewrite the equation as x equals 2 cosine 4t minus 7/4 sine 4t. Now, what it's asking for in part C is for the equation in the form of a cos gamma t minus phi. So I want to find my amplitude first. It's the square root of c1 squared plus c2 squared. So you've got 2 squared plus negative 7/4 squared ends up being square root of 113 over 4. So I've got square root 113 over, I've got square root 113 over 4. I did it in the other way. It'll accept it like that. I also put the same thing for amplitude. Alright, now I like to draw the diagram because it's cosine, 2 cosine. Because it's cosine, you're going to have this, this is going to be cosine, and that's going to be cosine, and then that'll be sine, and that'll be sine. So, you know it's 2 cosine, and then minus 7/4 sine. So, because the cosine is positive, the sine is negative, I know it's going to be in the 4th quadrant. So phi is going to be the arctan of negative 7/4 over 2, which is the arctan of negative 7/8. However, in the problem, it states that phi needs to be between 0 and 2 pi. Since this is in quadrant 4, the answer that I'm finding is going to be a slightly negative number. So it's not going to be between 0 and 2 pi, but if I add 2 pi, it's going to be an equivalent answer. So x is a cosine gamma t minus phi, which is square root 113 over 4 cosine of 4t minus the arctan negative 7/8, and then you add your 2 pi. The last part of this problem asks for the period. The period is going to be your 2 pi, it's going to be 2 pi over your gamma. In this case, our gamma is 4. So 2 pi over 4 becomes pi over 2. And that's it. I hope that clarifies things for you.